Hello, everybody. I'm Dr. Sri Banerjee, core faculty for the College of Health Sciences and Public Policy at Walden University. And this here, my friends, is a proposal for an interdisciplinary geospatial certificate program. I think it has been long since past the discussion about if geospatial skill is a necessary skill for our graduates to have. I think we've gone long past that discussion. Now the discussion is actually how are we going to implement this? How are we going to implement this necessary skill that all our graduates should have when they come out of Walden University? And so hopefully throughout this presentation, I'm going to be making the case for this. Before I get started though, let me give you a little bit of a background about myself. I have a master's degree from Johns Hopkins, and so and this is specifically in geospatial analysis. So I have a lot of very specialized expertise. I have a background of graduates who have expertise in this area, who have used this, in fact, on the ground, in the field, in Liberia, when the Ebola outbreak was taking place, unfortunately, and in other surveillance applications. I also recently actually received 1,000 hours of training in mapping and attended GeoWeek. I actually got formalized certification for this. I have a lot of training, a lot of specialized training in geospatial ideas and geospatial certification. And I also have not only training, I also have a lot of research that I've published. And so there's conferences all across the country, and these have been showcased in a lot of these places. I've also consulted with multiple individuals in constructing this talk. So the objectives, the objectives of this talk is to, of course, start off by exploring. You have to explore before you can present something. So what I'm gonna do is I'm gonna try to explore this vision for you. Explore this vision for the need for geospatial 2030. This was something that was delivered by Greg Scott, UN GGIM Secretary, and also former Vice President Al Gore, his vision. Let's start off by exploring their vision, and then let's present this geospatial ideology. It's a broad framework that I'm talking about. It explains various types of GIS projects and how this connects to sustainable development goals. And so these are all important components to be all connecting in one framework. And then sharing examples of cross-disciplinary applications of GIS, and sharing examples of curricula that are actually already in existence all across the country. This geospatial framework is not new. When the Sustainable Development Goals were developed, back in 2015 and is now still implemented. This is part of that framework, but it has actually more recently been further dedicated towards implementing some of these tools. And very, I was actually there in some of the initiation of the newer dashboards that have been created surrounding this. So I already told you about this a little bit, but Al Gore goes into talking about imagining a young child doing, just going to a digital Earth exhibit at a local museum, and after getting in a head-mounted display, sees Earth as it appears from space, and using a data glove. She zooms in and using higher and higher levels of resolution, sees the continents, regions, countries, cities, and finally individual houses, trees. So this level of granularity called digital Earth, this was only a vision when Al Gore was presenting this back in 1999, 1998 actually. This level of granularity now is such a reality that we don't even question this being as being something that can be science fiction. So this is how far we have come along. So of course, Walden, all of the curriculum in doctoral public administration, a lot of this is already integrated, and then now in some of the newly administered surveillance courses in both PhD and DRPH courses have specific activities that look at the opioid epidemic and have students specifically create maps surrounding this, at least within the public health side. So these are things that I think are activities that almost or all students, should I say, in our university can really benefit from. And I think that if we create some of these curricular courses, this can benefit us. So, for instance, of course, in business mapping, there's market segmentation and consumer research and advocacy and education. Of course, there's addressing disparities, and I've actually co-written about these disparities and providing resources in geographical areas in great detail. And then also in healthcare, areas needing naloxone for when people are in opioid crisis. Its relapse is not uncommon, and so naloxone is the only rescue that some people have. Thinking about vaccine administration, of course, geospatial applications are very much relevant. In counseling, identifying the mental health needs of the population and gathering special regional resources for crisis. And then even, believe it or not, even in criminal justice, I think actually very much so in criminal justice, providing better support to areas with higher incarceration rates to prevent recidivism and crime from taking place. Look, folks, I mean, we're not wanting people to um, uh, go back to the prison system. We want them to be members of society. And so geospatial technologies can allow for a lot of these to be better illustrated. And actually, in the market, if you look in job descriptions, have already is already been a skill that is being required by careers. So it's already out there. What I'm trying to say is that we can build curricular examples and can provide examples and cases and multiple cases where these can be built in, embedded within tailored curricula. So if you look at some of the disaster types, and this is one application of many in geospatial sciences. But if you look at many of these countries, the number of events actually vary. And so actually this is all within the United States, but the types of disasters vary. So whenever there's variance, you can map it in different ways. Um, And the other point that was actually being made in this slide was the fact that because of these disaster types, when you have students in different places and different locations within the country that are going through drought or that are going through flooding or hurricanes, then you can know through geospatial technologies that they are actually experiencing distress. So that was actually the important point. So here's the structure. 4 to 5 courses with the capstone. And so I'm going to go through a competitor analysis here. Bureau of Labor Statistics shows what's out there. Of course, there's some organizations, professional organizations that have a lot of different resources surrounding not only geospatial technology, but enhancement by artificial intelligence, photogrammetry, and AI. So this is a quick Bureau of Labor Statistics. I actually went into the database, and Job Outlook is on the rise, so which is always a good sign. So I think some of these estimates are estimates alone, and so I think if you see overall, and if you take a look at all of the different types of varieties out there, you'll see that the demand for geospatial tools and geospatial sorts of curricular pieces are really important. And so it's important to go through the skills and learn them in a methodical step-by-step manner, so that you can understand what is it precisely that you're trying to address. So here's all the titles of all the things that you can do with your geospatial degree. It's not something that a lot of people when they look at this, a lot of students when they first look at this list, they get confused because they think that they're looking at some other job prospect list. This is not a geospatial prospect list. But I'm going to guarantee you this. This is the job prospect of the geospatial list, and the one in yellow, data analyst, yes, that is one prospect, and I'm going to explain to you why. When you're actually learning how to create maps, you're dealing with quite a few data systems simultaneously, and you're learning to merge them, join them, and this is not only spatially but also within the database. And so when you're joining them within the database and understanding how to do this in a systematic manner, then you are effectively a data informatician, a data analyst, a data specialist, whatever your job title may be, a big data analyst. And so that's why this is something that is very widespread and broad. So now talking about geospatial intelligence, there's multiple types of geospatial intelligence analysts that you are capable of doing. I'm not going to be explaining every single one, but there's quite a few specialized ones. If you look at these, they don't really make sense on the surface, but if you know a little bit about geospatial, like imagery analyst, it doesn't take a rocket scientist to know what that means. Mid-sensor, mid-senior level geospatial intelligence analyst. Of course, we know that's with geospatial experts. So the trend, it's simple. It's expected to grow by the U.S. Department of Labor. Our educational needs, our educational resources need to address this trend. So we need to better harness university-wide applications. Education data to understand trends. Several efforts are underway in processing education level data, but our institution has several areas we arguably better serve the needs of the students and their communities than potential brick and mortar universities. And this may be more true in some of the southern states. And we've seen this where Walden is searched, and these are the places. Now, in the next part of the presentation, let's take a look at a sample master's curriculum. So, in a sample master's curriculum, one of the first curricula design you see is editing, geoprocessing, as you can see, as WebGIS would contain geocoding, image analysis, 3D, mobile and real-time GIS in a web environment. So these are all important components of creating any sort of, whether it's a master's curriculum, certificated curriculum, or some sort of curriculum. Geoprocessing and geocoding is key. If we're thinking about geographic information systems, of course, you have to be talking about the fundamentals of data structures. And this connection I was talking to you about earlier within the presentation, that data structures are a very important component of geospatial analysis. But also georeferencing, data classification, querying, cartography, and basic data, spatial data analysis, especially. So these are the first two, but there's additional curricular details that is important to be going through. Going through geospatial statistics, kriging is an important concept, and it serves as primer to more advanced advanced techniques in spatial statistics and also machine learning. So then that leads us to understanding spatial analytics, and that is including suitability analytics analysis, network analysis, and even spatial interpolation. These are three very, very important components of spatial analytics. And then we end with programming in GIS. And the components of that have been incorporated within that portion, which you can kind of go over on your time. But looking at the tasks, the GIS tasks, and the workflows in Python is important. In the last slide, I just gave you 3 courses, but actually, I lied. There's more. There's more options on courses, and these can be offered for electives. For instance, remote sensing, that's a good one. Systems and applications, development and management of GIS projects, GIS and spatial decision support systems, spatial data management, quality and control, cartographic design and visualization, and even drones and geospatial decision making. So these are really important, and just some more options on courses on electives to be thinking about. But wait, there's even more, and this would be considered advanced geospatial technology. And this is kind of integrating everything that you've known, everything just kind of coming together here to create spatial databases and data interoperability. And this is really, really key. And of course, when you understand how to have interoperability between different information systems, it's also important to manage those systems. So the infrastructure management is really important. Advanced topics in remote sensing as well. Now, when we're thinking about the remaining 3 types of advanced geospatial technology topics, these are actually really important, and so I tried to put a little bit more emphasis on this. And one is GIS for emergency management, and when we have disasters, and when disaster strikes, it's really important that geospatial management systems provides the infrastructure that allows for this management. And then geospatial apps, and then finally the system architecture for enterprise GIS. And so these applications, I've built quite a few for my YouTube channel, but there are quite a few that you can implement and really provide wonderful social determinants of health implementation. So now here this talks about some of the related geospatial sciences and predictive analytics that is available along with geospatial sciences. So we can start here on the left looking at big data analytics, some of the tools and techniques that are available in conjunction with big data analytics, and that is cloud computing environment, and that's in the it's building in Hadoop clusters. And these clusters are basically clusters of computing that are capable of handling large amounts, petabytes, large amounts of data simultaneously. So working with other open source technologies can be very beneficial. Something that is really key in the area of predictive analytics and data sciences is that there's a lot of new tools that are becoming available, in fact, as we speak. So the process changes constantly. So in terms of census data, which is a very crucial source of geospatial data, these data sources and Twitter feeds are actually constantly changing. So good to know the tools and techniques. And then census data mining is another good course with visualization and analytics. Something I will say about geospatial mapping is that the skill to visualize and skill to relate different variables is something very crucial to have. And so then that leads us to artificial intelligence and machine learning in geospatial technology. And so this is where there's geo AI and machine learning. In fact, the term geo AI in itself is a very popular term right now. And this is of use cases from various sectors focusing on prediction and optimization. Where are their correlations? Where's their patterns? Advanced object detection and automatic feature extraction. Advanced spatial temporal statistics, that goes without saying. Very important. You have to know how to process and relate the complex data sets in an effective manner. And then urban analytics is something that is very important application in that the cities of the 21st century, in fact, I would argue in the next decade, need to be a lot more smartly planned. I mean, gentrification is only one problem in urban planning. There's so many, which is a significant portion of how we can combat poverty, and we can actually address social determinants of health and equity. But I can see that there will be a digital transformation of urban planning, and this will allow for encouragement of community collaborative stakeholder engagement. And this is important to ensure sustainable cities for the 21st century. So this is looking into optimizing exploration of oil and gas fields. So I wanted to point out to people that there's quite a few applications of geospatial technologies, one of which is exploring new places where there's oil and gas industry. And so you can look more into this Pluralview technology on your own time. So this is all about thinking about techniques in an environmentally safe way. One part of at least geospatial technologies addresses this component of it. So if you want an integrated geospatial information framework, these are the necessary elements that have been identified by global public health agencies. I believe this is from the World Health Organization, but this is 9 strategic pathways which are actually anchored to each other. And I like the model of anchoring because the idea is this, that each concept is anchored to each other and connected in such a way that if one does not work, then the rest of them are not, rest of the anchored pieces fall apart. So for instance, let's take innovation. So one facet of technology is innovation. So if that falls apart, then of course you can't collect data, the standards fall apart, legal and policy fall apart, capacity and education fall. So all of these are anchored, and these are all in different levels. So one part is in governance, one part is in technology, and one part is actually the people, how it affects the people. Um, so if we use a cohesive framework for not only implementing and upscaling technology, but providing governance and having this for the people, then we can really have a cohesive geospatial information framework. So I'm going to go into each of these a little bit more detail and provide some explanations for these, because this is a very important framework that has been released from our global public health agency. So I think it's important to pay attention to. So the governance and institutions anchor, this is what actually establishes the leadership. It provides you with the model. There's a multidisciplinary, multi-sectoral participation and commitment to achieving an integrated geospatial information framework. The objective is to attain political endorsement, strengthen institutional mandates, and build a cooperative data sharing environment. So the roles and responsibilities can be fulfilled to achieve this vision of an information framework. This is a very busy slide, but the idea here is this. There are 7 underpinning principles. Strategic enablement, transparent and accountability, reliable, accessible, and easily used, collaboration, cooperation, integrative solution, sustainable and valued, and leadership and commitment. So these allow for methods to be tailored to individual country needs and circumstances. So these are the underpinning principles. What are the goals? Well, the goals are effective geospatial information management, increased capacity, capability, and knowledge transfer, integrated geospatial information systems and services, and an economic return on investment. So ideally what you would do is, here's the vision at the top, there's the mission, the strategic drivers, underpinning principles, and then eventually here's the goals for the United Nations Secretariat Global Geospatial Information Management at the end. So the 8 goals at the end reflect a future state where countries have the capacity and skills to organize, manage, curate, and leverage geospatial information. So what are the anchored, what's anchored by the 9 strategic pathways? And this is really important because it goes into some of these pathways, and that's governance and institutions, legal and policy, financial, data, innovation, standards, partnerships, capacity and education, community, and engagement. So you need all of these pathways to come together to create a geospatial information infrastructure. And the same goes true for many facets and many aspects of technology. Um, so what is the mission? The mission is there's chaos of information in the environment. There's data everywhere. There's just so much information. Make how to realign and make sense of any of it is anybody's guess. But data aggregation and disaggregation between national, state, and local levels, communication, linking up with other government agencies is important. And of course, a modern, agile, sort of policy-oriented framework always helps. So data is always and considered always to be one of many disruptive technology enablers. And applications are challenging the norm. So this was the 2030 agenda, of course, with the framework, and I wanted to quickly go over the 17 Sustainable Development Goals, but also the 169 targets that are associated with it, and the 232 global indicators to follow up and review progress. So these are implementation that's gone on via national processing, and so this is measured by statistics, but also, very importantly, geospatial information. So Earth observations and other big data observations. And this is coming from not only governments, but civic societies and UN system science and technologies. And so any national SDG implementations will be suboptimal without this critical geospatial information that is out there measuring, monitoring, and reporting certain things. So remember, people, people, prosperity, place, partnership, and planet. These are all of the areas. These are the P's. 5 P's that the Sustainable Development is pursuing to improve: people, planet, prosperity, peace, and partnership. That is the declaration. So back in 2018, the statement was made that if you really want no one left behind, then we have to start using geospatial information and geospatial data. Categories of disaggregation called in the 2030 agenda place or geographic location is critical for ensuring that no one is left behind. Geographic location is needed to know where a situation is present or where an event has occurred, and to allow decision makers to respond. So this is not even a new trend, because over 10 years ago, the United Nations had already made great strides in strengthening the global data ecosystem by establishing the United Nations Committee of Experts on Global Geospatial Information Management. So the geospatial community, working with the statistical community, investigated how geospatial information can be used for improving the production of the many SDG indicators. So they actually already in 2018 established a hub, and I encourage universities and educational institutions to explore similar types of things for interoperability of data sets. But a hub, which is a repository for national Sustainable Development Goal information, and will also transmit information to a global data hub. So a geospatial hub is almost inevitably essential in every institution. And so this can be a data information hub, but a place where people can come to kind of collectively create data information systems. So let's look at a map now. We've been talking about a lot of theories and why geospatial technologies need to be implemented. Let's look at a map. How is the annual mean wage? I mean, why go into it? Are you making any money? Well, as it turns out, it actually varies just like anything else. But if you're living in the Northeast, around in the New Jersey, New York, also in the Massachusetts area, Maryland, those are places where you make a little bit more money than say Oklahoma, Kansas. But of course, this varies a lot. This is only in 2021, so just take a look at the current literature and see what is going on there. But disaggregation by geographic location, this is something that is essential. If this is not taking place in your data set right now, then you are actually missing out on a lot of information that you could be collecting. And I'm not talking about small scale data centers or smaller projects or dissertations, which may benefit from, of course, geospatial sciences and definitely will benefit from this. But I'm talking more about also major data centers and data hubs. For instance, the Framingham data sets or even National Health and Nutrition Examination Survey, having geospatial data sets, more geospatial information available, readily accessible for people to freely download, I think is important. This is not currently there within the federal government. So I urge and encourage, if anybody's listening to this, to try to have NHANES provide some of this a little bit more. So there's disaggregation by geographic location, which what means that we're combining statistics and global and national aggregations with geospatial information. And then actually you can go even further and do some subnational disaggregation as well, and look at the local and also look on a pixelated level. So this is talking about remote sensing and photogrammetry. So this is an opportunity atlas. This is from a presentation that I did on Healthy People 2030 with Dr. Nina McCune back in the January National Faculty Meeting, and it provides a good framework and overview about all of the different places where there is more of an incarceration rate and higher incarceration rates, whereas some places are not as much. So this is a hotspot, an example of a hotspot analysis map, and some of the southern states have a higher propensity of this. So I encourage you to go into the Opportunity Atlas to explore this. Integration of statistical and geospatial data is crucial. One cannot go without the other. If there's any place that this is not taught in conjunction or in tandem with each other, then they're actually not providing you with complete information. The geospatial framework, it has to be usable, it has to be interoperable. Common geographies should be identified, geocoded units should be there, and then fundamental geospatial infrastructure needs to be part of this. How does this fit well or mesh well with statistical process modeling, GSBPM? Is that there's triple phase planning, pre-enumeration, enumeration, and then post-enumeration and dissemination. So there's and I've shown you this in different lectures before, but there's first in the statistical process, you have to first try to design and specify the needs. Of course, a lot of times that turns the other way around, but then you collect, process, analyze, and then disseminate and evaluate. So here's some examples of LiDAR data, remote sensed data, and you can see the details can get pretty granular here. Here's geographic disaggregation, and so and geographic aggregation examples of granularity and what types of information is available within the Moyobamba district here. So I'm trying to now wrap this up and shape this into kind of a piece. A potential curriculum, based off of what I've seen from Walden offerings and what I've seen Johns Hopkins and other places. I've done a lot of curriculum comparisons. I mean, I think it's important to have foundations of GIS, cloud, web-based GIS. I mean, cloud-based GIS is just everywhere. There are so many tutorials that I alone have made on this, but there's so much more out there. And Hadoop cloud computing and how some of that infrastructure works is also beneficial for students to learn if they want it to be competitive in the job market. And then geospatial analytics, of course, is of tantamount importance. And then finally, having some sort of capstone experience funnel projects allows students to really have some sort of final sort of reflection of what they have done. And here also, this is a good opportunity to teach some very advanced level skills and have students not necessarily understand all pieces of this experience, but at least go through the process and experience it so that later on they can understand it better once they have more of an understanding of geospatial knowledge. So there's many ways to implement actually, but there's 3 ways we can really get started in implementing some of these things. Is leveraging some of the microlearning opportunities and strategies, but also creating maybe a certificate program, maybe starting off with 4 courses university-wise, which is not necessarily discipline specific, but really broad-based, because geospatial sciences honestly is a very broad-based sort of discipline, and the tools apply in many different disciplines. I've shown you so many examples of that within this presentation. Also find and advise opportunities to integrate and infuse within each curriculum, within each discipline, within the university. So making a compendium of resources and lists where this is actually possible is important. Disaggregated data really is important to be focusing on, and this is really what even the American College of Epidemiology, after we have experienced a pandemic, have really concluded that disaggregated data provides much more information, much more granular level information about specific portions of the population rather than making overgeneralizations of the whole population. So the third part of this is building a research hub to expand on opportunities to optimize experiences for students to explore geospatial informed research. And this is important. Geospatially informed research does not mean having to always go out there physically and creating some sort of unique project. There's so much geospatial information. Actually, I would argue that it is more beneficial to be in your living room or in your room and exploring some of the data sets that are already out there and helping out in trying to decipher and use geospatial analytic skills that others may not possess, and do some projects. Get started with some free projects and then build your portfolio and do more. So these are three ways. Existing, of course, these are all the programs at Walden University. I don't have to list them out. Everybody knows what they are. Business and management programs, communication programs, counseling programs, criminal justice education programs, health and health sciences programs, information technology programs, nursing programs, psychology programs, public policy and administration, social work, and human services programs. And some of these are, I understand, in flux, but these are all the programs there. And why did I list them is because if you go through them and if you look at the curriculum, and I'm ending with Penn State's curriculum because they have very elaborate geospatial systems over there as well. But if you look at all the disciplines that we have at Walden University and some of the topics, geospatial topics that are available, they really mesh well. There's really complementary alignment between the geospatial curriculum and the various disciplines that are out there. What are some of the additional curricular ideas? I've given you plenty within the content of this presentation, but geographic information in a changing world, Introduction to GIS Science, wonderful course. Cartography, maps and map construction, image analysis, geographic information systems, Introduction to GIS programming. This is again a menu item of things that could be looked at for potential geospatial certificate programs, or maybe electives, or something in the future where students can acquire some skills in mapping. Here's a sample GIS certificate. I'm going to end with this. Fundamentals of GIS, GIS data forms design and quality, geospatial and environmental analysis, imagery, automation, and application, geospatial analysis project. Conclusion, wrapping this up, this is a long talk, but providing multiple options for various disciplines across Walden University is really always a good thing. And I think it's a good thing for us out there, for us to be innovators in providing data analytics, and innovators in providing the tools to be able to process the flux of data that we are now in currently. And if we're wanting to make improvements in education, we have to be creative and use tools to its maximum value currently, and technology to its maximum value, to be able to rebuild from some of the educational slowdowns that we have experienced collectively. Using a geospatial framework, it will bring together some of these sustainability principles that we're so often concerned about, and social and sustainable development goals. Goal number 3, having education for all. These are goals that really is fundamental to human existence, and needs to be addressed in a more complete level, and geospatial technologies will allow us to do this. These technologies will allow us to meet students where they need it the most. If a student is experiencing a hurricane, you as the instructor will find out more information about how this has affected people, or perhaps have more empathy for what they're experiencing, or even just be able to understand the situation. or geospatial technologies you can use better to have an understanding that, look, these relationships that you may be actually witnessing between, for instance, high blood pressure and cardiovascular disease may be strongly correlated in a certain part of the country, but not in another part of the country. So the idea that zip code matters more than genetic code is a reality. So we have to face this and understand that disaggregation of data allows for studying problems locally and in a way that it was never possible before through on-ground sampling techniques, but also aerial techniques. So thank you for listening. This is really something that is a crucial technology that universities need to adapt and be able to integrate widespread, not only throughout the curriculum, but also in ways that retention is studied and research is conducted. Thank you for listening.